Welcome to Brain Vision.
Hi everyone, so what we have is a refrigeration system with eggs, and these eggs are known to have a density of 67.4 pound mass per cubic feet, a specific heat capacity of 0.8 BTU per pound mass degree Fahrenheit, and an average mass of 0.141 pound mass. The eggs are placed in the refrigerator at a temperature of 90 degrees Fahrenheit and are cooled to a temperature of 50 degrees Fahrenheit by air that is moving through the refrigerator at 34 degrees Fahrenheit. These eggs are cooled at a rate of 10,000 eggs per hour. What we're asked to find is the total heat that is removed from these eggs and the volume flow rate of air required in the refrigerator so the change in temperature of the air is less than or equal to 10 degrees Fahrenheit. What we're going to do first is just state our assumptions. So we are going to assume that these are operating at steady state conditions, so properties are not changing with time. We're also going to assume that these eggs are at uniform temperatures before and after cooling. Next, we're also going to assume that the cooling section is insulated, so there's not going to be any heat transfer occurring that allows heat to escape this cooling section. And we're also going to assume that the property of these eggs are constant, so we can just go ahead and say properties as well are also going to be constant. And what we're going to do next is just going to use the properties of our eggs to solve for our m dot. So what we can do is we can say that m dot of our egg is going to be equal to the rate at which eggs are cooled, so that's 10,000 eggs per hour, times the average mass of each egg, which we know to be 0.14 pound mass. So what this gives us is an m dot egg of 1,400 pound mass per hour, which is also equal to 0.3889 pound mass per second. Next, we're going to do an energy balance and say that the total energy coming into the system minus the total energy leaving the system is equal to the change in energy of the system. However, recall that we are operating at steady state conditions, so this change in system energy will be equal to 0. So we can say that E dot in minus E dot out is equal to 0. Therefore, we can say that E dot in is just equal to E dot out. Now we can break apart these two values into its constituents and say that E dot in is just m dot times H1, and that's equal to the heat that is removed from the eggs plus the enthalpy that is exiting the system. We can solve for Q out, and that's going to be equal to m dot times H1 minus H2. Now we can use the definition of enthalpy to say that H is equal to Cp times T. Therefore we can say that this is equal to m dot egg Cp egg times T1 minus T2. Now these are all quantities that are given to us or we've solved for, and therefore we can get a total Q dot equal to 44,800 BTU per hour. And that is one part of our answer. Remember that we're also asked to solve for the volume flow rate of the air going through the refrigerator. So what we can do is we can assume that all of the heat that is lost by the egg is given to the air because we're assuming that the cooling area is properly insulated. Therefore, what that means is that Q out is equal to Q air. And we can go ahead and solve for the volume flow rate of the air, or the mass flow rate of the air first, by saying that m dot air is equal to Q dot air all over Cp delta T of the air. Now, we can look up in the table that the Cp of air is 0.24 BTU per pound mass degree Fahrenheit, and our delta T is given to us as 10 degrees Fahrenheit, because that's given to us in the problem statement. And what that does is it gives us an m dot air equal to 18,667 pound mass per hour. Next, what we're going to do is go ahead and just calculate the density of our air. So we can say that rho air is equal to the pressure over R times T, and this is just the ideal gas law. By looking up in thermodynamic tables, we find that the gas constant of R for air in standard units is 0.3704 psia cubic feet over pound mass Rankine. And we're also given to us the temperature. And what we can do is go ahead and calculate the density of air to be 0.0803 pound mass per cubic feet. Now we can put the m dot of air and the density of air together to find the volume flow rate of air by simply saying that the volume flow rate of air is equal to the m dot of air divided by the rho of air. And this gives us a volume flow rate equal to 232,500 cubic feet per hour. And that's our final answer.